Alright, we're live. Everybody, numerous of you today already. I guess that's what happens when I let everyone know early that things are going to happen. I'm just going to drop a few screws into this thing. What the hell, you're not even the right screws. This is the machine from last night. Just want to make sure it doesn't fall out in transit. It didn't come with any screws when I received it, so it goes back without any screws other than what I need to stop it from falling apart. Okay, man. And then we'll get on with the job of the next one. Okay. Murato's in here too. Martin, Blood, Jim, Pedro, Cordas. Of course, I saw you. The ITC. It is. I don't know about it being the best way to learn. Maybe the best way to learn how not to do these things if you want to make a living out of it. Okay, just make sure the sucker boots are still. It's surprising how many times that you can put a machine together, think it's all working fine, come back the next day and it's not. Like when I do when I'm packing up a job, the last thing I do before I close it all up is I open, the actual box and everything. I open up the machine, I put up the sticker of the shipping sticker and stuff like that, all the details, and take a photo of it to show that it's working as I'm just about to close it up and put it in the box. And every now and then you do get one that's just like, yeah, it's dead, and you're like, no. Alright, so this is fine. Yep, cool. So it can be a little bit terrifying doing that, because you're thinking, nah, I just want to ship it, I don't want to see this thing anymore. It's already paid for. Where's my green pen? There it is. Okay. Alright, that one's done. That can go express post tomorrow. Yeah, there were no screws with this one. Just came basically with the board in the chassis and that was it. A laptop. Sylvia. Gee, more 4 a.m. Crikey. 4 a.m. Where must you be? United States somewhere. Hey, Thomas. Reminds me I need to do the update. It wants to operate my 2442. You know what's sad about what I'm doing here? I'm putting these parts away, and these parts are actually functionally fine. There's nothing wrong with them. Because we found that the problem was the speaker amp. And so, other than the speaker amp chip in there, everything else was fine. But I do not like to reclaim parts in that way. I do not like to go, oh, well, that should be fine, take it out, put it into my tray and use it at a later date. I mean, it basically had to be extremely dire circumstances for me to participate in that kind of reclaim. Hey, Ed Boss. Hey, David H. Draco. Hey, Teresa. Seriously, dropping frame. What the hell is wrong with the internet tonight? I don't know what's up with the internet lately. It's really... I'm going to blame Brisbane and the cyclone. Hey, Fix-It Pro. Okay. Yeah, Maroto, with that particular board, there was the sort of, how could you say, confusing factor of the fact that we had also liquid damage parts. I mean, I suppose that should have led... I mean, I didn't rule out it being a speaker amp, and in fact it often is, I should say. But it was a case of trying to actually get to the point where I could prove it was a speaker amp. And particularly that the one that we pulled did not have any real visible corrosion on it. There was a little bit of muck, but that was it. Okay. It seems like we're back to normal behavior again. Alright, so I gotta try to remember what we're doing with this one. This is a 1814, so it's a A1990. Wait, what the hell was that other job? You A1990 as well? Yeah. Mm-hmm. Oh, there it is there. Yep. Okay, so we've got the same sort of board. Do we have the same sort of symptoms again? I think YouTube's suffering from not being able to keep up with demand. I mean, the amount of money they must spend just to try and keep up with demand and all that sort of stuff, it's just crazy. Storage costs alone. Alright, so this one's a bit... Oh, we are getting... Oh, yeah, okay. This one's tricky. So we're getting 20 volts, but we're only getting 50 milliamps. So, different sort of scenario. So, whereas the previous one, we weren't getting 20 volts. So this one's 20 volts, but it's not firing off. So we get the reset, then it goes back to 60. There's that little 100 milliamp glip. Hey, Jean-Marc. Yeah, that's right. Hey, Greg Foster. So yeah, this one's a weird one. You can see what it's doing. It's a very long cycle, and we get this like little 100 milliamp jump in there, and that's about it. The long cycle makes me... that sort of period of cycle does kind of feel NAND-ish, like it's coming up, and it's looking around for something, and then it just sort of shuts itself back down. So yeah, this is not quite the simple one. So what we're going to do is, because I have no recollection of a lot of it, go and have another look over the board. You never know. Sometimes when you just step away from a board for a day or two and then look over it again, you can see something fresh. Hey, Paul Howe. Yes, another day. Okay, so let's see, here we go. And yeah, people are going, man, we looked over this the other day. Come on, yeah, how many times have we got to look over this thing? And, well, we're just going to... Oh, that's right, right. See, it all comes back to me now. This is the one where we've got the liquid damage on the touch bar area. and that's all we've got. Have I checked to see if this is in DFU or not? I cannot recall. That's alright, we'll replace that bit there. Lots of things not related to the NANDs. But yeah, we found several small bits of corrosion, and we kind of hoped that they would be the fault, but in the end, in each instance, the part that was corroded didn't really relate to the style of the issue that we have. And that's the problem, and that's right, and it started out, so we could actually be just still staring down the barrel of damaged NANDs. Hey Zoltan, any idea why repair shops don't want to replace LED backlights and curves? Oh yeah, I can imagine why. That'd be hell. The chance of them damaging the panel during that process is so high that it's not worth it for them. It's bad enough for a flat panel, and anything over about 30 inches, it's just incredibly unwieldy trying to hold those things, Yeah, it's difficult to justify unless it's something where you've got a few thousand of them. Is that a crack under that? Unless you've got a few thousand to do, it's very difficult to make a business case for it. There's a lot of random bits of trash on here that at first glance you might think, oh, there's a fault, but it's, they're just random bits of trash. It's okay, those diodes normally do that, where they tilt off to one side. That's normal. Yeah, Sylvia, it's not very fun when things go wrong with those. I think flat panel is less problematic. You've actually got a chance if you lay it down on a cushioning blanket and you take your time. The other problem is if you do the backlight replacement type thing, you kind of have to do all the LEDs concurrently. If you do them just like individually, like, oh, there's a failed unit there, and replace it, you will end up with areas on the screen that look wrong. Like the coloration will be wrong. Even if it's the same original batch of LEDs, the problem is that the ones in there will have worn slightly differently to the new one. And so then you're going to get the customers complaining, say, oh, the colours look wrong in that area. And you're like, oh, good Lord. So you're sort of obligated to do them all at once. And nobody wants to do that. Yeah, CRTs basically just wanted to kill you. I swear I'm going to have to bring out the scope for this one and see if we've got any chatter towards the NANDs. I'm not exactly sure what I'll be looking for exactly on the, or which rail on the NAND, not rail, which lines on the NAND to look at. But I guess we're going to find out. But yeah, I just keep coming back to this failed connector, and I'm like, how are you responsible for this? And I keep wondering whether that lost via there is telling us a different kind of story or something. Because it could be that it's just staying shut, like the lid is saying. But although we did test the signal, didn't we? It was showing that we were showing open. So I don't know. I'll double check the lid signal. Eighteen 14. Thomas, I kind of hope I will beat you on coming back, but I can understand your perspective as well. But I'm kind of hoping mine takes priority. Okay. Wait, did we say 1041 or 1814? How can I keep forgetting? 1814, yeah. By the way, I've got this up here at the moment because I am trying to track a bug that occasionally shows up, and yeah, it's been difficult. Okay, so now we did check that those two rails were available, didn't we? Because that and that are the ones that are corroded out. And I'm fairly sure they both are present, but we'll double check that now. Mm-hmm. Alright, it appears we don't have that rail. Interesting. Yeah, that one. That one we do. Okay, so that's PP5E G3S DFR filter. This one might not be becoming present unless there's something there. That is supposed to be 1V8 Sleep S2. And we're definitely not getting that at all. Okay, the question is, should it even be present at this point? So we go back to the schematic. So this one here is not present. I'm trying to think. So we don't know exactly what state the board is in, but the fact that it's it's at 20 volts and it's doing some sort of cycling, I would have thought state S2 would have come up at some point. Anyway, let's see if we can track and find out where that emerges from. Okay, so it's on pin 20, it's on pin 21. Oh, and it's involved in the pull-up. Well, not the pull-up, but anyway, it's on this P-channel MOSFET as well. So basically we need lid open to rise, no, lid open to go down, which will mean then that will open, which means then that open L should be pulled up. Okay, let's find the source of that rail. Okay, we've got this chip here, U5104. Okay, so it's the 5-pinner next to it. Well, it's actually entirely possible something like that could get taken out. So that 5-pin chip there, we'll see if we've got the ins and outs coming into that. So let's see. So pin 4. So pin 4 hopefully should have something. Okay, we've got 3v3 there. Pin 3 is the enable, which is the bottom one here. Okay, so we don't have the enable, which is why we're not getting any power. So we do have power coming in, but there's no enable telling it to do something. I'm just going to hold it there, see if it kind of pops up for an instant or not. Hey there, Mark. 3186. Yeah, we're not getting an enable on that. Okay, so where's the enable come from? DFR power enable. Okay, so that's probably not going to apply power unless it can sense something's there. Let's see. So who's creating it? Ah, okay. This chunko is the one that will be emitting it. Like I said, we could be chasing something pointless here. I guess I'm only just going around checking to see things that I can test around the corroded area. So this is that test point that it was referring to. And we definitely don't have an enable on there. So there's probably a prerequisite that's not being met right now. I need to find a state indicator like debug. No debug. Debug LED. Why is there no S2 debuggy? Okay, then we go back to the schematic. So we found what we were looking for, the power state LEDs. There should be other things here that we can... here we go. SOC state. DFU status, 1v8 awake. Sleep S2R. The tantalums hadn't have anything around them, so they're just buffed, as it were. Hey, wrong way. Okay, well, I'm gonna find each of these on the board and then check. So SOC DFU status. So we're just going to go along and check these various pins and see what they indicate. Maybe we can find something of interest. Okay, this is SOC status. It's kind of weird to have 5 millivolts on that. That's kind of a odd value. Usually you just have like ground or something like that. That kind of thing. So, but having 5 millivolts is a little bit peculiar. Okay, this one down here is the force DFU. And this one here is just DFU status, and we've got 5 millivolts on that, so I'm not going to touch that. Let's see, 1v8 awake is up here somewhere. Somewhere? Where is it? No, it's down here. Okay, this is 1v8 awake. And we do have 1v8 awake. Okay, we got 1v8 sleep S2R. We do have that. It is a little bit of induced voltage, but I guess it's sort of like, it's, you always worry that maybe you've got a floating input somewhere and it's just sort of dragging up a little bit rather than being pulled actively down. Okay, if I've got 1v8 sleep S2R, then I would have thought I'd have 3v3 S2R, or the other S2R rails. Let's see if we've got 3v3 S5. We do not have 3v3 S5. Weird. Okay, now that is one I would have thought we would have. So maybe we've... And it's also sitting there at 2 millivolts. It's kind of weird. Okay, 3v3 S5. Maybe that's our thing to chase. Schematics. Now the fun part is I've got to work out who the hell makes that. I think that's coming out of U7800 Culp. So if we're lucky, we might have a bad cap somewhere around here. And the liquid damage was just a distraction. Welcome back, Avila. Yeah, this is fun. Okay, it's fun because on here, with these BRD files, they don't give you the actual BGA coding. So you basically just got, you got pins like, you hover over pin, it's like pin 260. It's not the normal BGA notions, which is like N10 or something. So I need to find, well, I need to find N10 as opposed to Ben 10. And what's painful here is that they don't actually have an associated anything with it. Okay, they're giving me, see, what have we got? Page 80, which I suspect is probably this page. Okay, it's the next page. So the question is, okay, this would be A1. You can go A, B, C, D, E, F, G, H, I, J, K, L, M, N, potentially. And then what was a 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, very close, but I don't think that's it. So we go this way instead. So A, B, C, D, E, F, G, H, I, J, K, L, M, N. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's it there, I think. Because the network name on these pins isn't always going to match what's on the schematic, unfortunately. Okay, so this is the area here. Oops, schematic, microscope. See what the diode mode for that rail is. So we should have about 0.47 on that test point above the current sense resistor, this one here. It's about 20% down. I'm not sure I could quite blame that. So we read 0.47, this one's 0.40. It could be just a system variance, but again, like with the previous one, we could be dealing with something very subtle. Can a schematic be generated from board view? Pretty much not. You can, from the schematic, if you have a board view, you can create the interconnects, but you need, you need to have the parts all laid out in the right place. So at best you can just simply get kind of a physical variation of the schematic, but you wouldn't know where any of the parts go. So yeah, the schematic provides the logical representation of a board, and the board obviously provides the physical representation. I don't know if that's actually responsible for S5. I am... Okay, where's Moroto when I need him? Like this here is not the S5 rail. Hey, Jason. Yeah, I'm definitely struggling to find this, like the source of this. PCH power. Could it be the... No. Oh no, Rilla, I haven't. Okay, so where does 3v3s5 come from? That's what we're trying to find here. So we've got 12, 17, 80, 15, 80. It's interesting that a lot of them referring back to page 80, which is the culp PMIC. And I mean, 3v3s5 is used everywhere. And this here is about the only thing I can... And the reason why I think it might be coming out of here is because they've got here the max current things. And this is why I know it's not that other 3v3. Because if you look at the max current, it says 500 milliamps. And so you're not going to be having a shunt sitting on that measuring 5 milliamps. Yeah, and I'm just wondering, yeah, an LDO supply, and I'm wondering if it's internal to the culp. But then I've got this problem of trying to find pin N10. Let's see, if I search here and I try to find the... So that's it there. Interesting, it doesn't actually list a external capacitor for it either, for an internal LDO. Anyway, pardon me, we've got 327 listed for it. So we will, let's see, we're on the other side of the board. We'll just find ourselves, okay, this here is probably a good spot. So we'll see if we can measure 327 on that pin there. That's just the SOT 23.5 there. And unfortunately, that's pretty much smack on perfect. Okay, let's see if we actually do get 3v3 out of it. Volt mode. And we do not get 3v3. So this is a real problem. So we're not getting 3v3 out of that, but we should be. Or at least I'd imagine. I mean, S5, you're not going to... and we've got one V8 S2. And it's not showing a... Yeah, it's not showing any sort of... what do you call it? Low resistance on that line. So if you got to ask yourself, what could be causing that to not produce 3v3? And that's why I would like to know if there is an external capacitor that is being used to support that internal LDO. So like you got LDO RTC, I mean that could be it, but yeah. Often they have it marked. It's not in a DFU state, and we've got a weird value on that. We've got that couple of millivolts rather than 0, but it's also not. Hey, Chart Show, welcome back. Thank you, Paul. Looks like sorry, Osis, I missed your comments there. Okay, we've got a core LDO. That might be something for us to check. So we're going to have to go around, check these LDOs, see if any of them are popped. So 7910. Oh, hello, Ben. Right, now that we know your name. Okay. So this is the core LDO. Now, it doesn't mean it is the 3v3 one, but I'm just sort of 430 ohms. Now, the trouble is I don't think there's going to be any other measurements that I can use on that. Now, the only thing I can do is take a dead board and do some comparisons. So these particular points are not exposed on a board normally. 7.4. Why don't you write on this damn board, Paul? So where's my pink pen? Pinky, where are you? Pinky's run off with the brain. Right. Okay, 1814. So there's a number of things that have been taken off this board, like the what do you call it, the CD32s and things like that. But overall, the inner core of this board is still intact. So, actually, no. Of all the things to take off this board, I have taken off the culp chip. Of all the things. Alright, well, we'll still have a look, but though it's going to basically measure open. It's just going to come up with a nice big open circuit. Yeah, there we go. OL, over limit. Okay, we've got another one we can. I'm just hoping I have another one of these boards, maybe 1700s. God damn it. 1041, 1041. This is not helping. 850, 1700. Really? I've only got the one. And I already packed away the one that we worked on last night. That's so not funny. Come here, come here, come here, come here. What have I got here? Hidden boards that I haven't yet. These are working boards. These are iCloud lock boards, and for some reason I have to keep them. I can't use them, can't let them go. It's like I'm some sort of demented hoarder or something. So What's this one? Reference board. Yeah, I just use them as reference boards. I mean, even this one. Look at this. This is a 2485, and there's nothing wrong with it apart from the fact that it's iCloud locked. But it's a reference board. I said, one day I hope to have enough surplus supply of cash that when new machines come out, I can be like places like iFix or whatever and buy one of the machines. So immediately I've got a reference, and we're dragging on our rendering again. Badly. I'm kind of wondering as well if Flexboard View's meddling with it. Sometimes it can thrash itself, but the thing is, the trick with Flexboard View is that it's a single thread only, so it's not really able to take down the entire system. Oh. Damn it. Well, this sucks. Don't have a reference board. God damn it. I think hoarding's common because the number of times you get caught out not having a reference board like right now. 400 ohms is a little on the low side, personally. I'll see if another board uses the same PMIC. That's what we can do. So we do search, part find. I think it was spelt like that. Yep, must be. Okay, there's no way 2849 has that. It's probably the same name, but completely. Okay, so 1040. Oh, 1041s do have it. Cool. Alright, stop. Okay, the fact that the 1041 has it and the 1700 has it, that's a good thing. So that means we can, because I've got 1041s and I've got 1700s. So we can use these as our guide. Yeah, it's very handy to have. And the design is pretty much identical. This will be it here. LDO core. Yep. So they've just cut pasted from the other boards. So now we have a reference without having a reference, if you know what I mean. I think 1041 and 1814. Oh, wow, yeah. This is the trouble when you store these boards in amongst each other. This sort of shit happens. They start knocking random bits and pieces off. It's almost as bad as being in a regular technician shop. Okay. So 435. So basically that matches what we saw on the other board. Hey, Lalo Ramos. Alright, so we can't blame that. Okay, so let's look for other. Suppose we could always try to replace the chip if we had to, but you know how I feel about that. I mean, I could be completely off base here. Okay, we'll try LDO RTC and PMU V pump, and what's this one? Okay, that's not required. We're basically looking for pardon me, we're looking for capacitors that just simply run off the chip like this, where it's just the one line into a capacitor and nothing more. So we have checked LDO core, that was no problem. So LDO 3 out, okay, let's try that. 7911. So PMIC. $53K, very hard to blame that. 300 ohms shorted cap. Yeah, it's getting really tricky with some of these. $79.02, which is the next one, 2 in. So this one here's the next one. 9 megs. I think we're pretty safe on that. 7901. This is the RTC one. This one here. 1.2 megs. Wow, yep, they're all good. Yes, I saw the revive, but the only problem I've got is that it's not actually in a restore state or anything like that. And so I'm not sure how I would be able to get it to do the revive when it's, I mean, other than just simply forcing it into the DFU and then doing a revive. But I really would have thought 3v3 RTC would be up. Not 3v3 RTC, 3v3 S5. It's kind of like a rail that I would have thought would be up no matter what. Oh shit, what the fuck was that? Mo! God damn it. What are you doing up there? What is it? Yeah, then come down. Yeah, well, come down. Come down. There you go. Yep. What? What do you want? What are you doing? Distracting everybody. Eh? Come on. Come, buddy. Oh, is that my 10 o'clock? Ha, okay. There you go. Yeah, well. Eat the bickies, I gotta do the insulin. Right, insulin time. Ah, we snoozed it, god damn it. Hello, Anderson. Anderson, thank you very much for the 50 Australian dollars, Anderson. I did not see that come in. I do apologise. I don't know how long ago that was, so feel free to wave your hand I've really got to... Yeah, there's just no time for me to get around to doing this thing. Hmm. I've got to do micros insulin now. Where's something? Alright. Damn it, where's Maroto gone? Oh, there he is. 3v3 sleep won't come up without proper comms between Cal... Is it Calp or Capel? Whatever. And the SOC. Uh-huh. Firmware corruption won't show DFU. You'll need to force it, but I wouldn't do this if data is important. Jeez. Yeah, this is a data job. So we're kind of in a catch-22 situation, aren't we then? I mean, we could do a revive. We could force it, then do the revive, and maybe it was induced into that state by the fact that the touch bar was corrupted. I need to migrate the connector across. So I guess the question is, if I put the touch bar on and I put it into a DFU state and then I try to do a revive and not actually a restore, I mean, we can always take that path. Revive hardly ever works. Yeah, I guess if you revive and something interrupts the process, you'll lose the master firmware table and data will be lost. Well, like I said, we're kind of in an odd situation here where I mean, without that 3v3 RTC, nothing else is going to come up. Not 3, I keep saying RTC, I mean S5. And if the only thing that's going to induce it is... I don't know. Take a moment, have a think about it, see if you can come up with something, because I'm sort of running out of options here. So first thing I will do is migrate the connector over so that it can sit in the chassis properly, because I know sometimes if the peripherals are not working properly, when you do a revive, it will get stuck in that. I'm just going to go do the insulin. Mr. Lee. Mr. Lee. We're calling him Mr. Lee. Mr. Lee, thank you very much for the 20 Australian PayPal. My goodness, the kitty cats are actually going to be over full this week. Too much food. I suppose it's covering vet bills from last week. Oh, gee. Alright. Start at the last rail you checked. What? Okay. Link to PDF in the Discord. Follows the rails on the review. Does anyone have circuit diagram for icons? Whoa, never heard of that one, Craig Jedi. Discord. Oh, you want me to run Discord on this machine? Alright, fine. Oops, ran 2 copies. Ah, there's Lee. Thank you, Lee. I never know whether to call people out by their name or whatever, because that's the only trouble with it's the only trouble with PayPal. It reveals a little bit too much information. Whereas at least, god damn it. What a horrible power sequence. Yep, thank you, Murata, thank you. See Jason's message earlier regarding touch bar. If there is a touch bar issue that causes it to lock, then use a good touch bar and pram it a few times in a row. You actually got one to come out of that after just pramming it? Oh wow. Normal. I can't say I've ever had that work for me. Let's see. Okay. Well, we're not starting from very far in here because we've got PP Bus. What's the 1598? That's an older one. We don't even get 3v3 G3 Hot, I don't think. Let me check, see how far down 3v3 S5 is. Is 3v3 S5? Oh, Gord, okay. It's way down. Okay, it's a lot further along than I was anticipating. I almost need to print this out on, like, A1 sheet. Okay, so this is one that we don't get. Where's our threshold for when it's... you know what? Yeah, I need to just pump this all into a OB data. What do you call it? Open board data. Oh, that's better. Yeah, that was my bad. I didn't think S5 was actually jumping too far, but obviously there's a hell of a lot of precursors coming into that. Okay. G3 hot RTC, G3 hot. Alright, time to go through the rails, folks. I don't need a scope for this, I just need to basically just go through and check them. No, we don't need market though. Some of these I'll probably be able to do overhead. Okay, so we've got 3v3 RTC. 3v3 G3 hot. Okay, we know we got 3v3 G3 hot. That's that one that we were measuring on the little 5-pin touch bar one. I'm pretty sure we had 1v8 sleeve S2R. Or did we? No, we don't. What? We don't have 1v8 sleep S2R. I thought we did. I could have sworn we had that one. Did we not have that? You did not. Was it the 3v3 that I thought we had? Joy, forgetting everything then. Oh, that's right. That came out of U 5104, and we. That's right. We don't have that because of the fact that it comes out of the U5104, which is fed by the 3v3 G3 hot. Wait, we should have that. We don't have the enable. That's right. Okay, that's where we're going funny there, because we need the enable for it to happen. So if we go to the schematics, so we're missing this, and we do have the 3v3, but we don't have the enable, and the enable comes from T2, right? So we're sort of dead-ended there already. This is where I find that sequences can be a little bit weird, because I feel like yeah, it's like, oh, yeah, you're coming out of the T2, so what is the prerequisite for the T2 to give us that signal? And so I feel like we've barely gotten started and we're already dead. Oh, actually, I just noticed something. This is for the DFR one. This is not the general one. Okay, there's my problem there. That was my first mistake. Actually, no, I've made many mistakes. This here is, notice it's got the suffix DFR on it, and that's because it refers to the one just coming out of here. It's not the general one, so that's my mistake there. Alright. That's why it's all confusing. It's a very different rail. Okay, now we're getting back to normal again. Okay, what way is our board up? This way. So Q6950. It's under here. No, it's not. Nope, that's it over there. I need the microscope for this one unless I want to smash some pins together and definitely cause an issue. Okay, we got one V8 there. And one V8 awake. I hate when I've got to go flipping back and forth between sides. You're on the wrong side there, buddy. There. Okay, we've got one V8 awake. I should definitely just put this sequence in as a, what do you call it? Open board data thing. 1V8 sleep. Okay, another one of these ones. PMU GPIO. Okay, that one we're going to have to skip because I don't think it really exists on this particular board. So the next one is going to be 1v1 sleep S2R. So like if I have this in a open board data setup, then it's very easy for me to step through. Maybe I should actually just show how that's done. Okay, we do have 1v1. Alright. Yeah, maybe we should have a little demonstration here. Okay, go to schematics. So what board is this? Okay, we're going to edit this file. Section start. So And what we're going to do is basically just put in all these rails. I wonder if I can copy paste. Much easier. Some of these aren't going to be applicable, but we'll find out on the way. Yeah, we're gonna just start with these ones. Save. I need my Vim. I can't do what I want without my Vim. Okay, OVD local, open with gvim. Okay, what have we got? 11 to 29. That should do. And we just got to reload this board. No, why you no work? God damn it. Try that again. There we go. Alright, now we're getting somewhere. So now all I have to do is anyone remember which one we were up to? I think we skipped that one. We did 1v1, so now I want 0v8. And you can see how much easier it is now. So basically I can just jump through and it's going to take me straight away to it rather than me having to type it out and search it and things like that. Anyway, so 0v8 we want. There's a little capacitor above U7800 there. Actually, is there something on the other side? There's a test point on the other side. Cool. So you can see how much easier it is once you take the time to do that sequence once, and the nice thing is, as Murito mentioned, it applies to multiple boards, so you can actually just copy paste that across. Okay, 0.8, we've got that. 0.8, 2, sleep DDR. Okay, bank at 3. Okay, yep, got that. Let's see, here we go. Yep. 3v3 awake. Little tiny capacitor above the NXP. Yep, 3v3 awake we have. Yeah, minus because I'm just holding the leads backwards. Okay, CPU, something RAM awake. One thing I'm just noticing is it's not favoring the test points for some reason. Like normally the way I've got the software designed is when you select a network, it should actually favor a test point as its spawning point like this. But for some reason it's not, so it might just be a side issue or whatever. I'll have to dig in and find out. Anyway, the point is, it's still perfectly useful right now. Point 0.8. I'm gonna guess it should be 0.8. Didn't actually say what voltage it should be, but we'll assume it is. 0v9 awake. Yeah, again, for some reason it's not picking up those test points. But anyway, that's just a small bug oversight I can fix. 0.9, yep. Hey, nuts and proud. So 1v1 sleep DDR sock fat. Somewhere up here. Yep, got that one. Use the half split method. I suppose I could do that, but I'm gonna be horrible and just go through it as I am right now, slowly, boringly. Okay, another test point there. I know what you mean. Yeah, basically just bifurcate the selection. 1.1. One V2 awake is up here. Hey Paul Norman, welcome. 1.2. VDD CPU awake. .75, that sounds about right to me. PMU sysalive. It's way over here. It's awake. PMU active and ready. Somewhere around here. Sometimes you do get them and they don't exist. That's always fun. Ah, there it is. Sometimes you're just looking in the wrong board area. Who would have thought? 1v8, that's good. Hey Bert Blankenstein. PMU cold reset low. Back over to this section. Where are we? There it is. One V8, it's fine. PMU VDD main enable. Over here. Three V3. 3v3 main power good. Oh wow, there's a teeny tiny one up here. Here it is. Yeah. And 3v3 main power good is also good. Yes, Paul, it is actually. Yes, laptop, they do jump momentarily. Okay, so we've used up everything we put in there, so I guess we better add some more rails in. So what's our last one? 3v3 main good. And that brings us to 3v3 S5. Okay, 58, 31. Ah. Okay. Okay, so it was that 3v3 main good was our last one. Okay, so that's our last one. So now we're up to here. And that actually doesn't show up. It doesn't look like that's a rail that's in this board. That one is. Just call me PLD, we'll be good. Clock 32, PCH, and we'll actually have to go into frequency mode for that. And what I'll do is I will actually pump this sequence up onto what do you call it? Onto open board data, so other people can use it. There's a funky looking resistor there on that clock. 3 caps. There, that. Look at that resistor. Looks like it's taken a bit of a hit. Yeah, it's just, I'll just change that to a different, once I find it. They're sort of like the refinement processes. Anyway, let's measure this, see if we've got 32 kilohertz at least. Although we're probably going to sag the poor thing down because okay, we have 32 kilohertz, so that's good. Yeah, sorry Craig Jedi, pretty much sold out. I've got to get my act into gear. There's so many things I've got to get done. You people are unrelenting. Okay, test point in the middle here. This is for PCH RTC reset. Switch back over to volts mode, alsjeblieft. Dankie. You're welcome. 3 volts. 5V G3S enable. Man, I've got to sort out this test point business because this is really annoying. That's why I designed it, so that it should focus on the test points. Okay, 3v3, that's fine, that's an enable. I don't know, he'll keep using Landrex. No, he'll use board viewer. There. Board viewer until the day he dies. There's actually a few people who are going to be using board viewer till the day they die. Partially because I've also pissed off some people. I didn't mean to, but it just happened, alright? Some people, when it comes to trying to help with okay, 5.1, okay, that's fine, yep. Yeah, some people, when they're trying to make suggestions or help with software development, they're better off not. It's just, yeah. I think I retaliate very poorly to situations where people try to leverage something over me. It's sort of like, oh, you know, no one's gonna use your software, or it's not proper if you don't do it this way, or yeah, just those kind of, that style of talk. Okay, this is slightly interesting. This is a 1.8, but it is an enable line, so I'm suspecting it's probably okay. A Para Wizard. Yeah, I'm getting better at pissing people off lately. And unfortunately, this particular person that I have pissed off, that's right, Jason. Jason's strictly forbidden from ever talking to me again. Yeah, unfortunately, this particular person that I've ticked off, they are a pretty popular person. And I wasn't trying to tick them off or anything. I just kind of I got short with them because of the fact that, you know, they just came in with this attitude and they did the usual shielding thing where they'll go, don't take it personally, I'm often known as being abrupt to people and stuff. And it's like, well, if you know you're going to be that way, don't be that way. Put some effort into not being a fucking jerk. Anyway, and I tried and I tried and I tolerated it for quite a bit. And I said, look, just let me do my process and I will try and rectify these things that you've suggested and take them on. But then after everything, they still came back and said, yeah. It was just that, well, no, I'm not really happy. So I'm like, I don't care, mate. You're done with me. Our relationship is over. I'm sorry. If you can't make the effort to try and be a civil person towards me with this, then I'm just not going to bother. Joey, it's always you. Anyway, this here, like I said, we're getting a 1v8 line voltage on it, but I suspect that's not going to be a problem because these inputs, anything over like 50% of VDD, so this will be 3.3, so anything over 1.7 volts is going to be considered an on. So I don't think this is it being 1v8 is fine. Yeah, Greg and Teresa. Yeah, when people precursor what they're about to put on you with the fact that I'm just like this, it's like, yeah, I know what you say. Just be better, do better. Yeah, yeah, with due respect and all that sort of stuff. It's like, give it up already. You're just using that as an excuse to be a jerk because you really don't want to be better. Let's see. So 3v3 G3S does not seem to be present under that label. And yeah, I tolerate a fair bit because I know this is how it is sometimes. And honestly, there are many times you don't want to miss out on some good ideas because you were snowflaking too much. So yeah, you take the hit, you turn the other cheek, and you sort of go, okay, let's just get on with the task, and we'll kiss and make up later. But when you get slapped again and again, it's like I'm done with it. I'm really done with it. And so I've burned the bridge. I feel like I've burned the bridge passively, but at the same time, I sort of don't feel bad about it. Even though this person is very popular and has a name that is similar to the one who is not so popular. And the worst thing is, technically, they're a brilliant person. I've got no qualms of the quality of their own personal work. But in terms of their capacity to collaborate, all I can say is they are not so great. So yeah, it's just the way it is. You can appreciate someone has exceptional talent in one area and at the same time say they suck in another. Okay, we've got something missing there. Okay, we're missing 5V G3SP good. Okay, so we're not getting power good. We finally found a point. Oh, are we? We getting it now? Damn it! I was kind of hoping I had it there. It was probably while it dipped them for a second. Nuts and proud. I kind of have to be. Irilla, yeah, I'm not saying anything Irilla, but yeah. Okay, that was just while it was cycling, so that's not a problem. Like I said, they're very good at their work. They're just not so good at that sort of thing. And in many ways, I guess I'm kind of guilty of the same. I tend to be very short with people when it comes to my software. Irilla, in a funny way, I actually find that, at least what I've sampled so far, I find those two people to be actually quite similar. Alright, come on. Is this going to come good? Because this should be... What are you? 32... Okay, yeah, we've got 32 kilohertz. 32768. That's good enough. Thomas, that's just when it's doing the reset. Okay. So we've got here what is this? SSD PMU reset L. Oops. It's over here in this area. Yeah, this could all be for naught. Which one am I after? This one. He was very bad with the battery tester manufacturer developer. Oh, really? Okay, so I'm not entirely alone, am I? Is that what you're saying? Yeah, there are empty paths there, but they're not relevant. They're just decoupling ones. Okay, so we're missing this sucker. We are missing SSD PMU reset L. So there we are. I'm in frequency mode. Thank you kindly. It should have still come up on my other display, but thank you. That may be the cause. Like the multimeter I have, it has a multi-mode display concurrently. Okay, there we go, 1.8. So much for that. It is an active low, so if it was low, it would mean it was in reset state. But it's not. It's high, so it's not in reset. The caps are fine. Yep. And now we're getting to the... Now we're just getting to the NAND stuff. So we'll see how we go. So we should have 0.9 here. Yeah, 0.9. Yep. And we don't have this next rail. It's the same, but it's the 2v5 one, so let's try that. Am I on ground there, or am I on 2v5? Okay, so we've got 2v5 as well. So yeah, 0.9 and 2v5 are both present for the NANDs. The battery tester manufacturer deserved it. Is more arrogant than Alex. Yeah, all this sort of stuff. Yeah, there's a bit of corrosion and whatever junk, but it's actually okay. So even though it's corroded and everything like that, it is okay. It's working properly. We are getting 0.9. We're getting 2.5. This is okay that it's missing. We tested that as well. Right, up here we've got SSD Ocarina Write Protect Low. And that's that one there. 1.8, so it's not in write protect mode. Some of these are a little bit tricky to get a hold of because of the shielding and stuff. Some of them I can't even touch. Oh, here we go. This one we can get. What are we looking at? Ocarina PFN. I'm not sure what PFN stands for. Power factor normalization. 1.8 seems fine. I've got to flip the board for this next bit. Where's Moretta going? At what point would I be okay to try that reset option. Like, what is the threshold rail? Okay, 1.8. That's fine. That's reset low. That's fine. Zero V9 SSD. We already know that. Pulse forming network. Is that it? Okay, thanks. I'm just going to jump over to PMU on off L. Yeah, it's cycling every 25. Yeah. Or roughly about that anyway. But yes. Yeah, that's the thing that's been throwing me as a bit of a weird thing, because it kind of feels like it's seeking out the SSD and can't find it. Okay, we've gotten all the way to PMU on off L, and now our next one is 3v3s5, and 3v3s5, as you know, is not present. So we've gone through that entire list. We just did PMU on off L and it was present. So we're now down to 3v3s5 and we do not have 3v3s5. PMU could be bad. It'd be weird for it to be bad, but hey, JFix. I mean, I can replace it. It's not the sort of thing you want to replace too eagerly. At least, you know, it is out in the open. Hey, Power Wizard. Yeah, the PMU at least is out in the open, as we can see. And there's no defects on the surface. There's a teeny tiny dot between the A and the 7 above the hyphen, but it's, as far as I'm concerned, that's more random crap. And it does still bother me in the sense of like, okay, if the PMU is bad, how the hell did it go bad? Okay, well, basically, if it's a storage, we're up the creek. So therefore, really the only thing we've got left is the firmware. Hey, Daniel Laser. Can anyone from down under send some warmer weather up here? Tariff-free. Tariff-free. Yeah, we're sort of coming to the end of our warmer weather now too. By the time we hit sort of late April, things are finally calming down. So, and these aren't SanDisk ones, so yeah, they should be okay. And it does bring up the whole history aspect, where, okay, so we had this, but I kind of got the feeling that this was done a long time ago, like that, knocking off that, and that made things work again for here. And then I feel like this was the new event. So, well, I'll put the new connector on anyway. I don't think we have a short anywhere, because like I said, we're not getting any significant spikes. Not that it matters. We saw that the last couple of nights. It could well be just a firmware issue, as Morito says. Yeah, Maruda, I don't know about interesting. Uh, but yeah, with the whole 25, 20-second thing, I'm thinking, well, everything's coming up to the point where it's looking for the NAND, for the SSD, and it's not finding what it wants. So that was why, that's sort of what's been throwing me the whole time. I'm thinking everything else seems like it should be coming up. And Thomas, that's potentially possible. So what I'm going to do is I'll get this connector back on and then put it into a chassis. I can try force the DFU. It's sort of a little bit against my philosophy, but I don't see many other options right now. Now, I don't think replacing the PMU's on the table for this one. It's, even though we're not getting that 3v3, I don't know, Also, because of the fact that when I check the resistance on that rail, it's within pretty much the same as what I've got on all the other rails. People are like, what? How do you get that plastic connector off without melting it? Wizard. Okay, there's a teeny tiny smidge of melt there, sorry. Not much. We'll go a little easier this time. It's we've got a 100 milliamp blip. Oh, and guess what? Dipshit Daniels hold on to the connector. What an idiot. Alright, let's do that again. Idiot. With these connectors, you can't apply any pressure to them while they're getting warm, because they will deform instantly. As you just witnessed. You can hold them by their metal bits, but you cannot hold them by the plastic bits. So you basically just have to put them where you want and then bring the heat in. I got vibration from the extractor kicking in here. Alright, so this is how you're supposed to do it. It's a little bit off center, but it should realign itself. Should. And if not, you tap it. There we go. I don't want to do it from the underside. I find that some people like to do it from the underside. I don't. It's not my technique. I find I'm perfectly fine doing topside work. No, Paul cannot speak. I rushed this one a little bit. It's still all good. We'll give it a bit of a Joey rub. A termination shock? Nah, man, just about finishing up here. I'm sorry, sir. It looks like that pin's not connected, but I'm fairly sure it should have reflowed. Well, thank you for saying hello. That is appreciated. Just switch to diode mode. We should have a value on that. Yep, 393. All good. Alright, so I'm going to leave this for tonight. I'm not going to do any further work on this one. And we will have a think about things, evaluate stuff. I'll have a chit chat to a couple of other people, see if anyone's got any experience with this particular style of failure. And then, yeah, I'll have to make a decision whether I will try and replace that PMIC. It just doesn't feel like it's the PMIC that's at fault. It's a perfectly clean area, all that sort of business. There's no shorting. It just does not feel like it's PMIC. Shouldn't be going by intuition. Should be going by facts. What we can measure, what we can see, prove. But the risk here that we have is, if we try to do, according to what Moroto is saying, if we invoke the DFU in order to be able to perform the revive, if the PMIC or the PM is faulty, then it may not successfully complete the restore, the revive, in which case then we lose the data. The other risk is if we replace the chip, we may not do it perfectly, and so we end up destroying the data anyway. So it's an evaluation of what's our risk factors here. Personally, I'm more and more erring towards it being a firmware issue, and I suspect it could have been when the touch bar got mangled up like that, because it was done pretty bad. It may have caused the system to get into a bit of a bad state. So that's my leading theory at this point. Anyway, so we didn't fix anything yet, but we are at least further along in the hole. And we also did a bit of a demonstration of how to do diagnosis charts, so that you don't have to do all the searching in Flexboard View or any other program and then jump back and forth. You can have it so that it's just there as a nice list, and you just go click, 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 work your way through them. I will have to find out why it's not focusing on the test points, because that is something that it should be doing. So I don't know what I've done with my source code there. I guess I'll be doing that after I've signed off from this one. So thank you everybody for being here, and thank you all for the contributions that were made, financial and advice. It's all very good. Helps. Just goes to show I'm just kind of cheating the system by making you all think that I know what I'm doing, and then getting you to all to make your suggestions, and I'm like, well, that was a good suggestion. Yeah, I'll write that down. So I appreciate it. Look, and I guess I'll see you on the next one, whenever that may be. But in the meantime, you all take care, and I'll catch you later.